Variants are a powerful way to give artists control over what kind of asset they're placing in a scene. However, we can also procedurally assign our variants using an expression in a set variant lop. This allows for randomization of our assets, whether instanceable or not. All right, let's take a look at the randomizing instance variants section of our example file. And before we get into this setup here, I'm just going to backtrack a little bit and look at this component output. And what we want to do here is make sure this set default variants is checked on and the material is set to block, which we do by selecting no variant. So basically what that's going to do is within the USD code, it's just going to write an empty string in there at the top level of that asset. Let's take a look at that real quick. So here's that mult variants.usd that we were writing. And if we look right here, we can see that this is the very top level of our asset. This is the top file that's kind of loading everything else in. And here you can see that we're writing variants equal string material and then an empty string. So this is just basically saying that we have an empty string set for our variant with our material variant, which basically makes sure that no variant is loaded. So this is just going to be an optimization that's going to help with viewport performance in Houdini while we're actually working on it. It's not going to change anything with the actual way that the code's written. You could do this whole next part without that being written and the USD files will be identical. It's just a little viewport optimization that helps it not have to figure out these competing material variants that are trying to be authored over each other. All right, so let's jump back over here. So at the top, we're just referencing in that mult variants.usd, same thing we just looked at the code of, and that's getting put into the second input of this instancer. Now inside of here, there is a grid that's created. It just basically gives us the points for where these are going to be instanced onto, just like you would with a copy, copy to points. We covered this in the last course in this learning path, the authoring course. So if you go back and take a look at that, that talks a little bit more about instancing. In this case, our instancer is set. The method is using an instanceable reference. That's just the most optimized version and kind of the one that you might want to use most often. So I have it set this way. It also works with other versions as well, other methods, but we're just going to work with the instanceable reference in this case. And then the only other thing that's really set different is the prototype primitives is set to the mult variants. That's basically just saying use this mult variants as one of the prototypes. And there's only one, so that's all there is. And then the index, you can set this however. You could do random, index, whatever, but it's going to just write the same USD asset to each and every point that's on that grid. So it's not really going to do anything different depending on how you have this prototype index set. So that sets up all of our assets, but now how do we randomize them? We talked about the set variant being how we do that. So let's now go down to this next node. And we'll take a look at what this is doing. So what this is doing is going over every primitive that's under the instance variants here. So you can see here our path is instance variants and then / instance star. And basically all that's doing is saying, look for anything that's instance and then has whatever at the end. And really all that's doing is making sure that we avoid this prototype. We don't want to really do anything to that because that's where it's reading the primitives from that we're instancing. So that is what we're going to instance, or that's what we're going to kind of loop over is all of those primitives. We're going to change the variant set geo. We could select between two, geo or material. And instead of choosing the variant by name, we're going to choose it by index. You can see here if we choose variant name not by index, we can just select that. We could select the toy. So it'll change all of them at the same time. So instead of doing that, let's kind of make it a little bit easier on ourselves and choose the variant name by index. So now this is going to randomize it because I have an expression in the index here. And so what this is doing is taking this attribute num variants, and basically that's going to return the number of variants on that specific primitive. We're going to subtract 1 from it. And so in that case, we're going to go from 3 variants to 2 because we want the index to be from 0 to 2. And we're going to take each prim here. So we're using the attribute @prim and getting a random number from that and adding a seed of 23 into that. And then all of that is being multiplied together and we're rounding that to the nearest whole number. So then that way we get 0, 1, or 2 for each and every one of these instance assets. So that's how we're getting this random kind of grouping of our geometry here. And obviously they still have no shaders because we've never set what shader variant or what material variant we might want to use in this. So that's what we'll do in the next node here. So we'll come down here to this set variant. And really the only thing we're changing here is the variant set. We're going from using geo to using material. Everything else is exactly the same. And so here I just changed the seed number. And if we come down here, we'll see that it puts a randomly colored shader on each and every one of these assets that we've instanced into our scene. And that's really about it. That's what we need to do in order to kind of create this randomization from this one asset with 9 different options for the variants to select from. So let's write this to disk and take a look at how it actually writes out. All right, so this is the instanced variance.usda or the rand instance variance.usda that is written out. And it's a not super complicated file. We'll just go through it real quick. We have the normal kind of header information here. Then we're creating a transform called instance variance. This is a group. We're also making a scope called prototypes where we're going to read from our instances. This is also a group. And this is invisible, so we're not going to actually see this when the scene composes. Then we're going to define multivariance, the primitive, and we're going to use the multivariance.usd as the reference for that. So that's going to reference that file in. You can see here that this is a relative reference, something that our USD ROPs kind of do by default, which is really nice because then you can pass this around and hand it off. So this is loading that file in relatively. And then we start defining our instances here. So here we define the primitive instance 0. This is an instanceable reference, so this is true. We have our reference here to multivariance, which is this primitive right here. So you can see instance variance, prototypes, multivariance. And so then here are the variants that we're setting. We're setting the geo variant to squab multvar, and we're changing the material to orange. And each and every one of these is going to have their own unique geo and material. So squab multvar teal. This next one here is squab multvar and orange. So each and every one of these has their own variants set on them. So really we can, that's the entirety of this entire file. We do that 70 sometimes and we get to the bottom, and really that's it. There's nothing else to really be added in this file. So that is how you can go and set your random asset variants programmatically or procedurally in Solaris. Now that we've covered many of the topics involved with creating USD assets, we'll go through a more practical example. In the coming chapters, we'll create the scene that is served as the title image for this course. These assets are free to download on TurboSquid, and the link to do so is included in the resources section of the course. We'll take a messy FBX file, automate the authoring of USD in Solaris, and save it to disk as individual assets. We'll also look into some ways to create variants by grouping these components into assemblies. Finally, we will randomly arrange these assets on several bookshelves and add a few other basic elements to create the finished scene. In this chapter, we'll look at how to automate the creation of USD assets when starting from a single, complicated FBX file. We'll first do some cleanup of the geometry and attributes in SOPs, and then bring that into LOPs using the component builder to help us properly structure our assets. We'll also look at a simple procedural shelf that we'll use in the finished scene. Okay, so we're in the Process USD Assets section of our example file, and you'll notice right away that there's a couple errors that are happening here. That's gonna be the case for a little bit until we run some of the automation that we have set up in this top network. But before we get there, let's take a look down in the SOP network and see kind of how we're cleaning this file up. The one that we've actually downloaded from TurboSquid, and the link for that is in the resources section of this course. So take a look at that, go download that file, and then we're going to load that into this SOP network here. So inside of Asset Cleanup here, you can see there's a decent network. It's pretty well annotated, so if you're really curious about what's going on in here, those annotations can help you understand that a bit more. We're not really going to get too far into it, but we'll just kind of say that you do need to load the geometry file into here. That's important to be able to kind of go through this next section of the course. So there's where the FBX will go. This section up here is basically just setting up. You can see here that we load in this file here, goes through a whole bunch of stuff in the middle, and then it gets down to this merge here, and really nothing's changed really visually on it, maybe some normals and things like that, but we've basically just set up some attributes that are going to help us kind of organize and process this as we go through. So take a look through here. There's some name attributes that have been changed, some enumeration of attributes and things like that. So and there's actually some cleanup that happened for one of this object right here, which I actually stashed in the file just so that you it doesn't have to run every time. So so then when we come down here, we see that there's a for each loop. This basically runs over each piece of the geometry, each name piece of the geometry, and basically just brings it to the center of our scene here, down to the origin and on the ground plane. Ignore the shelves. We're going to remove those in the next step, but basically everything's right here now and centered so that we can properly make these assets that we're going to populate our shelves with. Here then we change the scene scale because it's way too big. So we're going to do that. Change it down to a normal size here. We remove the shelves finally. There we go, no more shelves. So now it's just the kind of decorations that we're going to use. And then we split off the books because we actually want to make two different versions of those. So we want to make vertical and horizontal ones. I found it just to be a little bit easier to properly stack and put these on the shelves when they were in their right orientation without having to orient them and then stack them or organize them the way I wanted to. So that's just what's happening in this for each loop. It talks a little bit more specifically about what's going on in this little note there. Down here, we're just cleaning up some shader names and things like that, making sure that they're all coming in properly. And then this out decorations is kind of the final piece of this. This is kind of where everything is ready to go for automation. This last section is going to be sort of run by the automation step by step, because what we're going to do is look at this null here in our LOPS node and create work items based on the name attribute that's found there. So let's go back up here. We'll go to our top network, and that's what this first node in the top network is going to do. Now, if you know how tops work, you don't have to worry too much about this. You can just come back up here, right click on this, cook output node, and this whole thing is going to run. But I do want to just walk through it just to make sure we understand exactly how I set this up. But if you have a good understanding of tops, I wouldn't worry too much about this. You can just automate it. It's going to make a bunch of USD assets for you, basically. However, let's go through it here in this course so we can understand a little bit about what's going on here. So the first geometry import node here is going to look at that out decorations null that we had created. And when I cook this node, it's going to make 37 work items. Each of these is going to be using a piece name based on, that name attribute. So here's the piece value, which is basket 01. So now we have, this one's decor 02. This last one is vase 03. So there's a bunch of different names in here, right? So these are all going to be our pieces that we're going to be iterating over in this top network. So next we're going to do a ROP fetch, and this is going to look at the write to disk ROP that's in that same network. So if we go back up and over, we can see that, so it's going to start from this point here and continue down. Now it's going to actually cook the whole network, each time or whatever, but it's a fairly simple cooking process. So here, we're going to select only the current piece that is needed from LOP. So for example, if I come back up here and select just one of these, that's now going to be kind of our active piece. So now if I come back over here, it should be seeing that piece value attribute that's reading. It's saying basket 01 if I middle click on that. So now we can see that we're working on this basket. This is going to write all of our shaders into a detail array. This was something that was helpful for working with the shaders and things like that. So here we can see that we have all of our shaders written in an array. And then here we're also promoting a couple attributes that we'll need for the books and frames for their shaders. However, in this case, it's just -1 because it isn't a book and it isn't a frame. So kind of just an extra step. It doesn't really need to be done here, but this way it's just happening to each and every element, and we get those attributes properly. So then that's going to fire this ROP geometry output that is going to be fired by the top node. So here, when we come to this next stage here in our top network and we cook this is going to start writing all of those files to disk as BGOs. And so that's just kind of a nice way of caching it before we get to the next step of actually working with the USD side of this. So this is just kind of making a cache for us of all those different assets, and they're going to be saved to disk. So if we come over to our, intro to Solaris here into Geo, this is, all of these shelf decorations are going to be saved in a Geo folder next to your HIP file, and they're all going to be named in here properly. So we have all these different books and baskets and decorations and things like that have all been written in here. So we've got, some 37 different assets that we can work with. So then the last step is actually going to write these USD assets to disk. So I'm not going to do that just yet. We're just going to stick with, maybe we go with one of these books here. We'll start with one of those. So let's now go back up. We should see that this is going to start populating. So now inside this component geometry, this is loading one of those BGEOs right here. You can see it's loading piece value.bgeo. So if I middle click to evaluate that, you can see it's book 07 horizontal, BGEO. Great. So now we're just going to promote an attribute to detail here, just the poly, reduce, and convex hull. Those are going to get promoted to detail attributes as well. And then over here, this is really just the main geometry is going to be put into this default because that's going to be our render geometry. But over here, we have a way to basically switch based on if convex hull or poly reduce is set. Now, in this case, neither of them are. But if we go back and select one of these other things, like for example this basket, and come back into our component geometry here, this will actually now be doing, I believe a convex hull is set to 1. In fact, it is right here on our geometry spreadsheet. And so now if we come down here and look at the output of this, we can see that now this has a convex hull, and this is going to be used as both the proxy and the sim proxy. And that is going to be put into our scene graph tree, properly now with our hierarchy. So now we have it named basket 01. We have these different shaders created as geometry subsets, and that is all controlled up here in the component geometry. So we're partitioning the attribute shader. I just renamed it shader just so it was a little bit easier and it wasn't trying to do any automatic stuff with it in the USD side of things, so that it's not automatically trying to create these geometry subsets. Just made it a little cleaner for me to be able to work and figure out the best way to bring these things in. So in this case, we have shader. I've turned off this prefix subsets with attribute name. I just want it to be named what the shader is named, because in a second, we're going to use that to assign our shaders. So that's really the only thing that I've changed here. So in the next step, we're using the component material node, and this is going to use the piece value. So this is going to be basket 1 material is going to be the variant name. And there's no material assignments here. And the reason is because the material assignment's happening inside. So our material library lives over here. And this has all of the materials that we're creating, and one that we don't really need, but I just have it in there just for reference. This was kind of how I was working on the books, and I actually split them all out into individual ones. So if you want to take a look at that, that's a different way of setting up a book as well, or a multi shader kind of in one, but it was better to separate them out in the long term. So here, the component material actually has some stuff inside of it, which is going to set up our shaders. So what's happening here is the stage is being input here, and we're running a for each loop. This for each loop is actually going to run over each of the geometry subsets. So you can see here type geometry subset, and it's going to run over all of the primitives that are children of the geo primitive. So everything that's below geo, it's going to run over the subsets in here, geometry subsets. So that's going to basically run over checker, fabric black, fabric white, and inside. So when we get this material library here, you can see that there are going to be fabric black, fabric white, checker, all of those different ones that we were looking for are going to be in there. So that is going to match up, and we can then use that name of that geometry subset to pull in those shaders. So that's what we do right here with this graph branches. We're basically looking at bringing in whatever the iteration value is, and just the end of it, which is going to be, in this last case, inside. We're going to use that source prim path asset material inside, which is coming from right here. So asset material, and then we scroll down, there's inside. So that's getting grafted over right here into the material primitive underneath it as a child. You can see that's set right here, asset material. And here we then assign it. So that's the inside material being assigned. You can see it's, off, on right there. So now the inside material is getting set, and the material path is just coming from that same parameter that we had set here. I just had a reference to that parameter, and then the primitives are just going to be the iteration values. So whatever the subset that we're working on is where it's going to be bound to. So that's going to work and get us our geometry subset that we want to match up. So that's that is what happens inside of here. And it does that for each, in this case, 4 of those, adds in those 4 shaders. And now we have a nice clean asset. And the reason I did it this way was so that we weren't loading every single shader onto every single asset. This is a way to kind of keep them separate. You could do that where you just simply put the material library into here and didn't have to do all of those same steps. You could just kind of simplify it a little bit, but in doing that, you get a much messier asset, and I didn't really want to have that as our example. So finally, it's just standard component output here at the end. The root prim is just the piece value instead of the name of this node. So that's really one big difference. That piece value is coming from tops, remember? And so that is what that's what's being used as the name of these root primitives. And then, yeah, that's pretty much it. I changed a couple things here and changed these to USDAs just so we could take a look at them if we wanted to. However, we don't really need to because this component is going to be created the exact same way as the rest of the ones that we've done in previous chapters. So what I'm going to do is just go back into here and process this final step. And this will take a few seconds just because it has to create some thumbnails and different things like that as it goes through. So I'll wait here and come back when that's done. Okay, so that process has completed. Let's just jump back up and just double check to make sure that these are looking good. So we can just go through and select a few different ones of these. We'll see different shaders applied to these books and different assets and things like that. So everything seems to be working just fine. Yeah, everything's looking good. And we should be able to just continue on with the process. So the last thing we're going to look at is just this bookshelf down here. What this is just just a really simple bunch of boxes that are created in here. There's some controls. If you want to change these around, feel free to. However, I just have them kind of set to whatever I thought was the best. You can change different number of shelves here. We could change the panel thicknesses, things like that. The height of this ground panel here, a whole bunch of different stuff. You could change the overall shelf dimensions as well. However, I'm just going to leave it the way it was. You can take a look at how this was built. This really isn't about, a modeling course, but there's, an example if you want to take a look at, doing some procedural modeling. So what this is doing is taking in that geometry. Just zoom out a little here to the size of that. There we go. And we have just a simple material, just a cream colored glossy material that's being applied to the bookshelf. And then we're just going to save that out to disk. Nothing really fancy here. Location is changed just so that it saves next to the other ones. And I'm just going to hit save to disk and we can check that out. We can come back over here, go back up to our USD and the asset building course. And if we look in here under our assets, it should be a bookshelf right there. So there's our bookshelf, all the files needed. So all good. We wrote that out to disk. And going forward now, we're going to be able to use both of the assets that we've created here and this bookshelf to start processing through, creating some assemblies, and then finally assembling our finished scene. Assemblies are simply a packaging of components with the possibility of adding some new geometry and materials. Here we'll look at the process of manually creating 4 variants of our 2 basket and 2 pillow components. We will manually place the pillows into the baskets and set up the required properties according to the guidelines. Okay, let's take a look at the Create Basket Assemblies section of our example file. So here we have a primitive that we're just going to create to start our hierarchy. Here it's just going to be called Basket Variants. This is going to be an assembly. This is the first assembly that we're creating from the components that we created in the last chapter. So we're going to make this assembly here of some basket assets and start to put those together and make variants from them. So we have an assembly, it's an X-form primitive, and we're just defining it. So pretty straightforward. I added a null here just for visual reference, just so I know that, okay, this is the basket primitive that's coming in. And then down here, we're going to author a bunch of different references and kind of modify some stuff, move things around so that the variance, makes sense. You'll see in a second how that works. And what we'll do is we'll follow this path down first, take a look at these baskets that are made here, and then just quickly go over these because they're pretty much identical on both sides of this this network here. So we're doing this all within an add variant, block here. So this top node is actually performing a layer break, so nothing above it is getting written. And that's just kind of a clean way of working, just to make sure that everything's kind of contained inside of each of these variants. You're not writing anything else inside of there. So that's just the way that we're doing it here. So let's first take a look at this here. So we have a reference that we're going to be using to reference in our basket. And so we're going to be using basket 01 for this. So here, if we look down here, we have basket 01. The primitive path we're making here is basket variance, basket, and then we're using the source name, which is just the end of this file path. So here we have some primitives being created, basket and basket 01. Now this basket, we actually want to be a group and not an X form, just a plain X form like that. So what we're going to do is use a configure primitive in the next step to change the kind to group. So here we have a group kind. You can see that this has a new little icon here, and that's just basically going to group together the other components that we're going to load or reference from disk into this assembly. So here we've got our basket variant / basket set, and that's what's setting it to group. So if we slide down here, we're going to see that this null is going to be kind of setting up the names of our different variants. Each of these is going to be coming into this multi-input here, and that is going to set the name for each variant. So in this case, this one's going to be called basket 01 empty. There's going to be one called basket 01 pillows, basket 02 empty, basket 02 pillows. So so this is the empty version, so there's not too much to go on here. It's just a reference. We've kind of configured it, and this will be what it looks like when we load this from disk. Now let's follow this next path down here, and we're also going to reference in some pillows. Now those should be inside of here, kind of hard to see because they're all kind of on top of each other here. We could, let's see, we can just hide this real quick, and we can see that there's 2 pillows that have been loaded in there. So that we will do, and you can see. So okay, so now we have our pillows here. So we have basket and pillows. We have 2 different pillows that we're referencing here, and we're doing that just by doing a little wildcard after our pillow here. So pillow underscore star and pillow underscore star here are both going to load in both our pillow bunny and pillow hedgehog that we've created from that last automated step. These were named just from some attributes that I created over there in the last chapter. And so this is going to load both of those pillows in, put them both underneath this pillows null right here. So you can see here we have basket variations, pillows, and then source name. Since source name is just this part here, it's going to load in 2 different primitives here, and these have all the hierarchy set underneath them as well. So those are all, well put together assets that we can then use and reference in our assembly here. So we're just going to clean this up again, configure that pillows primitive to make sure that that's a group as well. And then let's transform these pillows kind of into position. So this first transform is going to transform the bunny pillow up, and then this one is going to transform that hedgehog pillow up. So now we've got some pillows sitting inside of this basket. Just makes for maybe a little more visually interesting decoration to put on a shelf. So now we have our basket 01 pillows set here. And then the same thing is going to be true of this other reference here for basket 02. This is going to reference in this smaller basket here. There is that reference from disk. Again, we're configuring that to reset this to be a group kind. It's this null is going to show just the empty one. And then we're going to again reference in the pillows, configure, and transform. So if we take a look at this, it's the same smaller, shorter basket with 2 pillows in it. So when we come down to here to add basket variants and take a look at this, it's just going to load them all up at the same time into memory. So now we have a primitive path of basket variants. We have an options block set up here. The variant set is going to be model. And we have the source primitives coming from the input, that's the previous input here. And then the name is going to also be from that input as well. So here you can see op input. This is the previous input that's coming in here, basically just saying up one level coming in, and then input. So this is setting our variant names here. So that's the variant name default. This is the variant source primitive. So those are the things we need to have set on our add variant node here. So that's all creating all of the different variants that we need. But there's one last thing that we need to set up, and that is going to be our class. So we can again just add a primitive here that's going to set up a class, and this is using the same basket primitive here. So this is setting up basket variant, class with basket variants after it as a child primitive. And you can see here now we have class basket variants, and that's coming from the input primitive here that's coming into this null right here. So we're using, we're looking for basket prim and the input primitive there. So that is our primitive, and then we can create our inherit from first input. We're setting up again the prim path for this primitive here, basket variants, and we're setting the primitive path to be basket variants here. So this is all very similar to how we've done it before with creating a class and things like that. And if we want to take a look at all the variants that we've authored to disk, we can just use this explore variants here, or that we're about to author to disk, I should say. These are the different variants, so there's 4 of them. So we have the empty, pillows, empty, pillows. So those are the 4 variants that we created there, and we'll be able to switch between these just with one node and be able to say, pick whichever variant we want to use. All right, so let's write this file out to disk. This is only going to create one file for us. That's going to be an assembly. So let's take a look at this file and see what it's doing when we open it up and kind of inspect the code that's inside of it. All right, so here is our basket assembly.usda. Obviously in a normal workflow, I'd probably save this as a USD file just straight up, but I want to be able to inspect it, so I saved it as a USDA. So we have our inherit set up here. We've got our transform basket variants, the inherits to the class, which will be down at the very bottom here, class primitive basket variants. So we have that inherit set up. This is an assembly. We have the variant set to basket 2 with pillows. It looks like that'll be our default when we open it up. And then we're prepending the variant set model. So now here's the variant set model. We have basket 01 empty, which has the transform basket, which is a group kind, and we're defining basket 01 as this reference to basket 01 on disk. Then we look at basket 01 pillows. This is obviously going to be a new variant in this set, and this is also going to reference in basket, the group, basket 01, and here's the reference from disk that it's going to load in. And now we have pillows. So we're going to have the transform pillows. This is going to be a group kind, and we're going to define the pillow bunny, which is loading that from disk. And this also has some transform information because we're transforming it from where it sat kind of at its origin point. And again, here's the pillow hedgehog that we're defining. It's loading in that reference, and there's transform information for that as well. So as we scroll down, we're going to see now basket 02. This is going to look basically the exact same as basket 01. And then here's basket 02 pillows, and this looks exactly the same as basket 01 pillows, maybe just with some different transform information here. So this is a pretty straightforward asset that we've created. There's nothing really overly complicated maybe going on here, but it's good to see how these assemblies could be written to disk and take a look at kind of how things are referenced inside of it and what it looks like when we save this to disk. And in the next chapter, we're going to do maybe a little bit more advanced version of creating some assemblies. In order to create the next 2 assemblies for our scene, we will use for loops to make our variants. Each variant will scatter the same books but use random seeds to produce different book ordering, all while keeping our assets the same size. Okay, let's take a look at the create vertical book assembly section of our example file. So here, like I said, we're going to use for loops in order to create our variants. So we have a for loop set up right here. We can see that our add variant node is inside of that for loop. And what we're going to do is scatter some referenced geometry using an instancer. So that's basically the whole of what's going on here as far as lops. Now there's a little bit more going on inside of the instancer, and we're not going to really dive into that too much. It's a little bit more just standard Houdini geometry manipulation, but just know that I'll kind of open it up and just show it to you, and that'll be pretty well commented in the demo file. But let's just take a look at what's going on first in the just in our LOPS context here. So what we're doing here is, so just that this is a layer break at the beginning of this for each loop. There's not really anything happening there. Now this is our reference node here, and what we're doing here is we're referencing in all of the vertical books that are in our folder. So we have our shelf decorations folder, and this will just basically bring in all books, because the only thing that has an underscore vert is going to be a book underscore vert. So whatever book underscore vert that we're bringing in, you can see right here, we've got book 07, 08, all different books that are coming in. Also, we have our decor 0601. We're just bringing in that one. Just we're going to use that as a bookend for each side of it. There are two. You could change that up and have them vary a little bit, but we're just using the one just for simplicity's sake. And what we're going to do here is we're going to stack these out based on their size, basically their thickness. So we're going to have them all in a line, make sure that they're spaced out properly, and then just randomize that a few times. So so this book line up here is going to do some geometry manipulation inside and create a bunch of points that this is going to be instanced onto. Here you can see that we have a bunch of books in a line here. All of the books that we brought in are being randomly scattered here, and then there's two bookends that are being added here, and one's rotated 180 degrees. So what we're doing here for our instancer is we're actually using that to create our main primitive, right? So we're creating our assembly primitive from this instancer. So here we're saying variant source $OS. So here we're just using book lineup, the name of this instancer, as our node name. We're setting it as a primitive kind of assembly. And here we're just using a point instancer. Now, in our previous part of this learning path, we talked a little bit about point instancers. So you can, and other instancers that are out there to use. I just used a point instancer because it's kind of the quickest and easiest. You could use one of the other ones as well. There was no reason to go into any more complex setup. Point instancer will work just fine. And then the target points are coming from our internal network here. And what we're doing is we're selecting the prototypes that are coming in here based on a name attribute. So if we go inside of this, we'll see that there's a little bit going on here. Basically what we're doing is we're bringing in all of the, from that input, we're basically creating just a little library of geometry basically that's coming in, looping over that, finding some attributes from those pieces, basically using this attribute from pieces here. It's basically you take in a geometry library on this side and a bunch of points on this side. And that allows us to kind of copy the parameters over, the attributes over from one to the other. And then we're just basically doing a copy to points here, doing some bounding information, matching some size with them. And then, we're basically relaxing these points in order to make sure that they're set apart properly with the p-scale. So there's not a crazy amount going on in here. There's just a little bit of back and forth with some attributes and making sure that they're set on a grid and things like that, relaxing the points to make sure that their p-scales are set the distance apart, that the thickness of these objects are. There's a couple other ways you could have done them. I've actually thought of a few more ways since I've started recording this course, but this is basic. This is just some basic geometry manipulation, and there'll be some comments in here when you download this file for the course. So it'll talk you through it in a little bit more detail. But basically what we're doing there is now we're instancing these, each book is getting instanced onto those points using this name attribute. So the looping really comes in by basically, we're setting 5 iterations here, and we're using that inside of this instancer to basically set our random seed of these points. So if we come in here, we should be getting that random seed right here. It's shuffling those pieces. It's using this random seed right here on this attribute from pieces. So this is where we're getting that iteration value coming in, and it's setting the seed based on that. So each loop of this for loop gives us a new seed. We come down here. Those are all written out now. They're all as variants. They're set up that way. And then we come down here and we have our primitive basically here. And this is adding our class primitive here. So that is being added. In fact, we have 2 slashes in there. So I'll just take that out so that it's properly set up. Cool. So we have our class primitive created here. And then down at the bottom here, we're going to just link those together and make sure that our reference primitive from class vert books is being, the inherit is made on the vert books primitive. So that links those together. And then we're going to write that to disk. So let's just take a look at these different variants that we've authored. They're all the same number of books. Now, obviously, you could change the number of books, do a bunch of other things here. That would just complicate kind of my scene building at the end because we'd have varying sizes of these assets, and I kind of want them to all be just the same size so I can just basically block out a certain area on these shelves that I'm going to populate. So I'm just doing it for my own ease of use. You could, at one point I did have them at varying numbers of books that were being copied. The options are obviously limitless, but this is just giving you an idea of how you might go about doing something like this. So we've made 5 different versions of it where the books are all slightly scattered differently, just to give some variation to our scene. So I just want to jump back to this add variant here and just specify what's going on in here just a little bit more clearly. So our add variant here is using the primitive path vert books that we've created here. And its primitive kind is going to be an assembly. And we are also going to be using that as our, we're using variant source as our source primitive. So if you look here, the instancer is using variant source /OS. So that's where it's creating this instancer from. And then down here, we're just kind of cleaning it up a little bit by saying vert books is the name of the primitive. That's the name of the assembly we're going to end up writing to disk. And the variant names that we're setting is just going to be vert books with bookends _ iteration. And that's just going to be a number. So each of those variations are going to have vert books with bookends _ number. So this is how we're actually setting up the variants and the naming that you'll see inside of the file in a second. All right, so here's the vertbooks assembly.usda. Basic stuff at the top, the kind of header information that we've seen in all of our USD files. And then we're going to look here and see that we're defining a transform vertbooks. We've got our inherit setup that we did to our class primitive. This is a kind assembly. And then the starting variant basically that's going to be set by default is vertbooks with bookends 4. That's just the last one that was created. And then we're prepending this variant set model. So here's our variant set model. These are going to be all the variants that we have the options to use. So here we have vertbooks with bookend 0. So there's going to be 5 of these starting at 0. This again is an assembly. And then we're going to define the point instancer that we've got created over there. And this also is going to be an assembly. So here we're going to we've got a bunch of different information here, orientations of our instances, positions, just some different primitives, primvars that have come in from the geometry inside of the instancer. We could have cleaned that up, I guess, at the end to make a little bit less information here, but you might use that, especially the name is going to be one that you're going to use often, for setting up your instances. So you kind of can't clean that up. But anyways, these are what we've set up here basically. And then down at the bottom is kind of the most important part of this. These are our proto indices. And so these are the prototype indices, right? So we have, in this case, we have 10, 4, 9, 2, and so on and so forth. You can see that 10 is at both sides here because 10 in the list is our decor 01 or our bookend. So we have bookends on either side, and then in between we have a random numbering of these other books, only being used once though. And as we come down here, we can see what all those prototypes are set up as, and they're just set up as references. So each of these are defined just as a reference to a file on disk that we've already created. So these are very basic setups. That way we already know that we're bringing in that file from disk. That's exactly what we want. And it'll be portable, right? These are all relative. So we're able to just move this whole folder somewhere, and we'd be able to load these files just the same as if we had them on our computer when we were writing them here locally. So really easy way to kind of be able to just reference these in and instance them. And this is going to happen on each and every one of these different each and every one of these different variants that we have set up here. So these are all going to look identical. There's not really going to be anything different except the order of them in their proto indices here. And positions might change slightly, but more or less they're going to be exactly the same. And then at the very bottom, we're going to have a class vert books. So that is the vertical books assembly. All right, now let's quickly go through the horizontal stack assembly that we've created here in this section. This is really similar to how we did just in the last section that we looked at. We have a for each loop. We're referencing in all of the horizontal books here. And we don't need the bookends, so that's just the horizontal books. We're going to use an instancer to stack them. And we're going to make sure that they're in the right order. It's just going to try to, load them all, reference them, do all the stuff inside of there. Again, this is going to be a very similar network. It's slightly different, but very slightly. And so that is the instancer that's going to set up these vertical stacks of books. Here's our add variant that's going to be used here. So I've got a little error going there. Let me just double check that. Yep, just locally, internally, it's not seeing the iteration until we actually run the for each loop at the end. But here we're going to have the book stack iteration using variant source, which is how we're writing this up here. And then we're going to be setting the primitive path to book stack. So this is going to now create book stacks like this. So it won't say variant source, it'll be book stacks. And we get to our end of our loop here. We're going to have the same setup here. It's going to have 5 variants set inside of it because we should have done that here in our iterations. We have 5. So that is working the same. Then we're going to set up our class primitive and finally set up our inherit reference here. That's going to go between those two primitive paths. In fact, again, I had this extra slash in there. So I'm just going to clean that up so that that is correct. And now we should be good here. We've got the right primitive paths set there. And if we explore these, you'll see that there's all different stacks. Again, you could do them multiple heights and things like that, but there's not, again, in the same situation here, I just basically made it the simplest thing for me to be able to show just the concept of how it's working. So there are the book stacks. Let's write this out to disk and we'll take a look at what this looks like. All right, now here's the book stacks assembly, and really most of it's going to be the same. This whole block up here, although the names are different, is going to look exactly the same as the previous one. And in fact, it's even using bookstack 4 as its default, just because that's the last one that was being made. Here's where we're going to start creating our variant set, starting with bookstack 0. We've got our point instancer set here. And just a bunch of positions, orientations, some of the primvars that have come through from the network inside. And then here is the list of all of our prototypes. And again, we're going to have our proto indices here, and there are going to be, it's only going to go up to 9 because there's not that 10th bookend that we're bringing in. And these are just going to randomize each and every time. Here's our prototypes that we've created with all of our different referenced in geometry that's coming off of disk. And this is going to repeat itself 5 times. Really, it's a very similar look, similar looking file. It just makes 5 different stacks of book with different indices for where the prototypes are going. So here's the second one. Here's the third one. Here's the fourth one. And then here is the 5th one. And then at the very bottom, we're going to have a class and book stacks. So hopefully this gives you a sense for how you would maybe do something like this with making a bunch of variations in a loop and being able to set that up in a way that you have some control over how they're randomizing. And then you could obviously go even further, change the amount of books that are being put in between the book, in between the bookends or maybe on the stack. There's a lot of options here, but again, this is just to give you an idea of how you would maybe go about doing this in the most straightforward way. And then you can kind of branch off from there and find different avenues to make even more variation on your variants. And in the next chapter, we're going to actually kind of bring this all together and start putting things on the bookshelf and setting it up in order to be able to render. This last chapter will bring together multiple elements in this course in order to make a renderable scene. We'll create some scene-relevant geometry, instance our components and assemblies onto our shelves, and then set up the scene to render. All right, let's take a look at this final section called Instance Decorations and Render. So in this, we're going to build a couple of pieces of geometry that'll act as just some generic scene kind of elements, bring in our bookshelf, load everything onto our shelves, set up a few things to render, and then we'll have a renderable scene to be able to take a look at. So let's first just walk through how we have this scene set up here a little bit. So we just created a floor and some walls, nothing fancy here, just simple geometry that we're bringing in. Loading that into this under this geo primitive as components. And then we're adding a configure layer here just to make sure we're saving this scene geometry as its own file. From there, we're referencing in the bookshelf that we created a few chapters ago. And this bookshelf, we're putting it under this bookshelves primitive because we're going to have a couple bookshelves duplicated, which we're going to do in this next step here, where we're taking the original source primitive and just duplicating it 4 times and offsetting it a little bit in Z position. So, and in this case, we're using the source primitives, our first duplicate. So there's just 4 of them. That makes sure that there's none that are just like hidden or extra primitives that we have to just kind of ignore in our scene graph tree. So that is our scene kind of geometry that we have built there. And from there, we are going to next reference in all of our shelf decorations. So these are all the decorations that we kind of automated through in the first part of this bookshelf kind of scene building. So if we look here, we'll kind of go through and see all of the different references that we're making. There's 6 different reference in this multi-parameter section. There's 6 of them, but that's going to load more than just 6 because we have some wildcards in there to allow us to load things in a little bit easier. So here we have our shelf assemblies that we've built. So all of our different basket, book stacks, vertical books, assemblies, and our baskets are all in this shelf assemblies. So in that, we just use this star.usda in order to simply just load everything that's in that folder. All of those are good to go, so we can bring them all in. The next one down is just our clock. That one is just named on its own, so we just have the clock that we're bringing in. We have a few that are named decor 0 something. And so here we say basically bring in 02, 03, 04, and 05. We can see those right here in the scene graph tree. And next we have our frames that we're bringing in. We're just saying frame underscore star and then frame underscore star USD since those are named the same. And that should bring in our 3 frames that are right here. Next one is just our plant vase stand, which is named pretty much on its own. So we're just bringing that in there by itself. And then finally, we're going to bring in our vases. So we have 2 vases that we're bringing in. So we're saying vase underscore 0 star, which just means anything that 0 anything, and then vase 0 anything.usd. And so we have 2 that are coming in here, vase 02 and vase 03. So that basically brings in all of those primitives and puts them into just kind of the root of our scene. And we're going to use that with our instancer here. So what we're going to do here is look at all of the shelves that we have here. So we're going to isolate just the shelf components and just the top of the shelves. And we're going to use that to kind of say where we're going to put our elements in our scene. And we could have done it with a scatter and things like that. I did it just with a line so that they're just all in a line. And there's, I think, 4 per shelf. It's a pretty simple way of doing it. You could certainly do it in a much more organic and complicated manner. But I just tried to do it as simple as I could. So we'll give this a second, let it kind of load itself up and kind of process everything that's going on inside of this instancer. Give it a second. All right, so that did a bunch of stuff internally. So let's just open this up and take a look at it here. So there's a for each loop going on inside of here. We're bringing in all of our objects from our second input there and basically putting them onto just the top part of these shelves. And we're making some points here basically in a line. We're using a line right here and matching the size of it to each element that we have coming in. So each of these tops of these shelves are basically being matched size with this line. And, we're scaling it down a little bit and moving them around, making sure that they're relaxed a little bit so that these individual pieces kind of are moved apart from each other, but there's only about 4 per shelf. So the relax is basically just figuring out the rough scale of these and then moving them around based on that. So I will make sure that this is a little bit better annotated in here for the final scene that you'll be downloading, just to help explain a little bit better what's going on in there. So we have all of our elements instance on the shelf. And now what we want to do is, since we have these nice shelf decorations that like have instances, right? These are all the same, or have variations. These are all the same variant, right? So each of these is the same exact variant. There's no difference between these or the baskets or anything like that. So let's go through and randomize some of these things. So if you remember, we used that same method that we did before, where we're changing the index here. In the variant set is model that we're going to be looking at, and we're looking at all the basket assemblies. So let's go to this. It's going to do a quick randomization, and now we should have some baskets that are tall, some that have pillows in it, some that don't have pillows in it, things like that. So we're getting a bit more randomization on those. So some are tall and short, all that kind of stuff. So now we have that all set. Let's take a look at the book stacks. That will randomize our book stacks for us. These will be the vertical stacks of books, so these should all now randomize and be all slightly different. There we go. Now we have different book stacks here. This one has this like zebra one on the top. This one's brown on the top. This one has a thicker brown one on the top. So they're all been randomized now with their variant selections. And then finally, we're going to do the vertical books, the ones that are standing up. All right, so now those all have randomized variants as well. So that is all looking good, and we can now go on to configure this layer here. So now we can configure our layer and set this up to save to disk. Basically, we're going to save this as layout.usda. We're going to add some scene materials here, just some things that we're going to use for the ground and the wall, and assign those. Set up a configure layer here to save out the materials that we're working with here. That'll just kind of set our scene materials and things like that. Anything that is extra here for us. Add an HDRI to the scene. It's just one of the default HDRIs that's loaded with Houdini. This one here is the noon one. Add a camera to it. So now we can take a look at this, and we have our render camera. Here we have some render settings. What I'm going to do is actually render this with the CPU engine, just so it doesn't mess my microphone up while I'm recording. But it is actually built for the XPU engine, so if your computer can handle it, go ahead and turn that on. My microphone just runs through an AI denoiser, so my graphics card kind of goofs with it a little bit there. So, then finally, we're going to have the configure layer here that we're going to save all of this render information to its own file, just so that's saved on disk. And if you remember, when we run this USD ROP at the very end and save things to disk, that's going to save not only our shop master, but also it's going to make all of these configure layers that are up higher in this network run as well. So let's save this to disk here. And then before we take a look at all those files, let's look and see how the actual render is working, and just make sure that we've got all of our shaders and things in there. So staying right here, I'm just going to come over and set this to Karma. Okay, so we can see that the shaders are all loading. Everything's rendering out properly here. It's a little slower than it would be with Karma XPU, but in this case, just kind of proof that it's working and that everything is rendering out just fine. And what we can do is let this run for a second, just to make sure that everything looks like it's working, and we can just kind of move around, make sure it's responsive and everything like that. Looks like it's working just fine. So now let's take a look at the actual files on disk that we wrote, and we'll see how the actual USD was written for this scene. All right, so here are the files that we just wrote to disk, and we'll just kind of walk through them and see exactly what's going on here. So first of all, our shop master is a very basic file, just sublayers in the 4 other files in this folder. So we have scene geo that we're sublayering in, layout, materials, and render. So this file is basically just loading those specific files from disk. So that's really all we're doing here, nothing really else happening. So let's walk through this next one, scene geo. This is just creating our geo, defining the floor primitive, and then writing the information there, all the vertices and attributes and things like that. Then we're also defining the walls, that this is a component, and then writing all of its information there as well. So this just is our geo that we wrote from that specific scene, not anything that we're referencing from disk. Now, really the main file here is really the layout. This is where we're doing all of our referencing and loading all those files from disk and then aligning them and arranging them where we want them to be. So first of all, we did the bookshelves. Here we have over geo, we're defining bookshelves, and we're going to define bookshelf as a reference to bookshelf.usd. And then we're going to be defining each of the subsequent bookshelf, like bookshelf 1, as a reference to the original bookshelf. But in this case, it has a transformation offset here. So we're actually transforming it and moving it, each of these along. So each one of these are going to be the same. So bookshelf 1 through 3, these are all going to be the same thing, just with a slightly different offset in its transform. Next, we're going to find the shelf decorations. Here we're defining that primitive, and it's a group. And then we're going to define the prototypes. So these are all the options that the instancer can pick from, right? So this will be invisible. We can see right here, there's a token visibility set to invisible, and this is a group as well. So then this is going to define all of the different assemblies here. So here we're going to use the vertbook assembly. We're going to bring this in from the vertbook assemblies.usda. This is going to bring in from vase03, vase02, the plant vase, different frames, some of the decor, the clock, and then our different book stacks and basket down here. So these are all the different options that the instancer can choose from. And then down here, we're going to start instancing those specific elements. So here we're going to define basket assembly. This is going to be instanceable. We're going to add the reference to the basket assembly, and the variant we're going to set is basket01 pillows. So let's just look at this one real quick. I'm just going to highlight basket assembly, and let's just scroll down here and we'll see some more of these. Like for example, here's basket assembly. This one's basket02 pillows. If we come down here, this is basket01 empty. So each of these has their own variant set for them. Let's just do the same and see, find our first of the books that are our vertical books assembly here. So this one here is vert books with bookends 3. Let's just go down a little bit and we can probably see another one here. This is vert books with bookends 2. Scroll down a little further here. We're going to see this is vert books with bookends 1. So these are all our vertical books. And then finally, we should be able to find one of our stacks of books here. So let's look here. We've got our book stacks assembly. And so this one is going to be book stack 3. If we scroll down a little further, we're going to see that this is going to be book stack 0. And then a little further, this one is book stack 1. So everything is really sufficiently instanced and randomized. So we have all of these different random elements that have been added to our scene. And really that's all that we're doing in this layout file. There's not really a whole lot else going on at the bottom here. And it's just defining where all of our instances are going to live in this scene. So it's a long file. There's a lot to it, but really it's fairly straightforward what it's actually doing. And then finally, we're going to be looking at the materials here. This is going to set up our shaders that weren't in any of these assets, these components that we built on disk. So these are just things like our concrete material and references to some other things here for images and things like that. And then bricks, our brick shader, and that has a bunch of image references and things like that as well that we're using for that. And then down at the bottom here, we're just setting up the material binding, basically like where that's bound. So we're binding it to the floor and the walls. So the last piece of this is going to be our render settings. This is where we're going to just define some lights. This is just going to be our HDRI right here. And then some information for that, things like our texture file that we're using, different parameters that need to be set for that. Cameras, this is just going to be setting our final render camera and putting it inside of an Xform cameras. And then finally here we have our scope render, and this is going to give us our different render products and information from Karma, different things that are set on that as well. And that really is the last element of this scene. So those will all compose together and create that final scene that we saw in Houdini.